Welcome. Great. So many of you joined us. I hope it's not because you don't care about testing. But today's topic of ours is using Symfony forms with rich domain models. As I said before, there is a lot of code. The contrast of the projector is at the limit, but we hope it will work out. The slides, of course, are online afterwards, so you can check out the details, and the code is on GitHub as well. Yes, welcome. Let's start. At the beginning, who are we? This is Christian.
Hi.
Who works as a software developer at SymfonyLive in Germany. And you may know him as Xabu from GitHub, because he's Symfony core maintainer and team member of the docs. Yes?
Yeah, and this is Christopher. He's a colleague of mine in Germany at SymfonyLive. He's a consultant, and yeah, he's also one of the organizers of the Symfony user group in Berlin. So if you ever make it to Berlin, yeah, maybe you can arrange that and go around and have some nice evening there. Christopher will also guide you through a small example application that we created in preparation of this talk. So he will explain you what classes we created and what we have to look for. If you don't understand everything of the code, that's not bad. We have uploaded the application on GitHub, and we will publish it later on today, so you can just read the application afterwards, look at the code, and also ask us some questions on GitHub later on. So yeah.
All right. So we want to do it quite hands-on. So we have a simple use case, which is a simple product CRUD. CRUD, acronym for create, read, update, or delete. I think you're quite familiar with the concept. And it looks like this. So we have products and categories, and we can create new products, and we have forms for that, for creating and editing those objects. The domain is we have a product with a name, a category, and a price. A category having a name and a parent category, so we can, it's not mandatory, but we can create tree structures, for example. And we have a price entity as well, having an amount, a tax, and a currency, of course. So not that complex, just a very, very simple e-commerce example. All right, and we're focusing on the product form today. So we're focusing about the controller and the form type that is dealing with creating and editing a form, so product entity. Okay, so we're going to solve this use case a couple of times. And the first time will be the standard way, with this, which is quite according to the best practice approach of the documentation. So the implementation starts with a simple controller. It's a form action dealing with a product type, binding the request to the form, checking if it's submitted or is valid, and then persisting the data of the form in a successful validation process, and then adding a flash message and redirecting to the dashboard. So nothing very complex, and in case it's not valid or is not submitted, we render the form with errors or just plain. Okay, and second important thing is the form type. In this case, it's straightforward as well. We have a name, we have a category which is an entity type, and we're just using the category name as label. Then we have a price amount, which is a money type with a divisor of 100 to be more accurate while calculating with the price. And then we have a person type and the currency type for the price tax and the price currency. And very important, we use the data class option of the form type to bind it to the product class, to our entity. Next up, our model, so the product entity in this case. We have a private ID, we have a private name with assertions on it using the Symfony validator component. We have a category and so on with getter and setter. So nothing special in here. We have getter and setter quite, we need to null those type hints because the form component needs it. So we get to that later on. But no surprises, very straightforward.
So let's have a look at what is going on behind the scenes when the user is interacting with our form. So this is what the user is looking at in the browser. They are entering some data, and then finally they are going to submit the data. The browser will then transform the data here into an HTTP request, which looks like this. So all the data are embedded into the body of the HTTP request. And then our front controller here will transform the incoming data into a request object, which is coming with the HTTP foundation component, which you all know from the Symfony framework. And such a request looks like this. So the plain data being sent there are transformed into a structured array, and this one is then passed to our controller, as you can see here. And this request is then passed by our controller into the handle request method of our form object. And the form is then responsible to map the incoming request to our data model. So here we are making sure that the data is actually a product object. And this is the final result based on the incoming data submitted by the user. It's quite complex what's happening behind the scenes, but nothing that we have to worry about because the form component is dealing with all the hard stuff for us. We just have to write a little bit of code. So let's have a look at what is actually involved into all this stuff that is going on when we are dealing with forms. So from Symfony's point of view, we are using a front controller, which is basically the one we got when we are bootstrapping a new application using Symfony Flex, or if we have an older application, it was maybe based on the Symfony installer. We are using the HTTP foundation component, which is an object-oriented layer on top of the HTTP protocol. Of course, we are using the form component because we are dealing with forms and we don't want to reinvent the wheel. And we are using the validator component, which we have seen in our model class, where we have all these assert annotations, which are ensuring that our model is always in a valid state before we are submitting or persisting the data to the database. Then we have our domain, which is the core business that we are dealing with, which is basically the product class and the category class in our example. And finally, we need to write some glue code. We need a controller which deals with consuming the request, pathing it to the other layers of our application, so the form component and so on. And we need to write a form type, which is a class which tells the component how to map incoming request data to our data model. Basically, if you just take a pen and then write a nice diagram, it looks like this. We have the front controller here taking the request, passing it to a concrete controller, which receives the model and then passes it into the form. And this is then dealing with our form type, and from there on, data is being mapped back to our model. Quite complex if you look at this from just what's going on behind the scenes, but we didn't have to write that much code.
Okay, so you have seen the model, and it's just private properties with plain getter and setter. That's what is called an anemic domain model. An Anemic domain model focuses on data, and it's structured. So I defined all the properties I care about. And it's very easy to implement. I define the properties, and if you're using PHP Storm, or I guess there are plugins out for every IDE to generate getters and setters. You don't have to write them, right? And it contains little to no logic. So if you have seen the getter and setter, there was no if or condition or assertion, anything else. There was assertions about the properties by which were used by the validator component. But the model itself does not contain logic in this case. So, so there's no guarantee that this model is in a valid state. And it's not guaranteed that the data set you're dealing with is consistent. Because you can manipulate every property for step by step, and you don't have to do a transaction which might modulate the data set in a valid way. So the rich domain model is the thing we want to look at today. And the rich domain model combines data and logic. So we have the data like before, but we have also logic that brings us a valid entity by design. So it's quite easy to test because we can write unit tests for state transactions and stuff like that. And the good thing is that we have defined state transitions, like when we have a category, we want to rename the category. And we can define which parts should be changed on a rename action. It's quite easy. You can set the name. So that would be the same like the set name before, but you could change things related to that. And our example with a product will use, for example, a rename method instead of a set name method. So what's the difference? It's quite hard. You all know Stack Overflow, and Stack Overflow is strong with opinions sometimes. And there was a guy in 2003, you may know him, who wrote, Anemic domain model is an anti-pattern. Okay, so people get confused. Is Anemic domain model an anti-pattern? And there was a discussion how they differ and how to avoid them, and finding the right balance between using Anemic and rich domain models. And in 2017, someone said it's not an anti-pattern anymore. Some said it's solid. Some said it's an anti-pattern, it's not solid. So it's Stack Overflow was very confused, and Spoom summed it up how not to agree about software development, software design, sorry. So it's not, we don't want to tell you that's better than that. It really depends on the use case, right? So if you're using Anemic domain models, they're perfect for prototyping. You can generate a lot of code and use it, and that's a good advantage. It's very easy to use, and it's easily generated. Rich models are more clean code. The testability is, well, you can test setters and getters as well, of course, but there might be no sense in doing so. And it's truly OOP, object-oriented programming, because you try to limit all the concerns of that object in that object itself. And it's up to you. We want to show you how to use rich domain models. We don't want to lecture you to use them. They are one option, and there is another option as well, so that's why we're pointing out the difference.
Okay, so let's take a look at our model and try to rewrite it a bit so that it's more rich than it was before. And we can start with our product class. The first thing that you may notice is that we have removed all the validation constraints on top of our properties. We don't need them anymore because our model should ensure itself that it is always in a valid state. And how do we do that? We have a constructor that receives all the attributes that are required to initialize a valid object. And then we are doing maybe some validation rules here. So we validate the name, which must fulfill some constraints. We will see that below. And we will pass a category object and a price object. And since the category and the price class do behave equivalent to what we have here, we can be sure that both of these objects are valid as well. So nothing more to check for us here. We also changed our accessors a bit, so we now have a rename method instead of the setName method that we had before, and we are calling validate name here as well. So we are sure that the same business rules that we are applying in the constructor do apply here as well. Set category now is named moved category here, which feels a bit more like what the user is doing really in this place. And here's our validate name method. Sorry, it's quite simple. We just check that the name is at least 3 characters long, but this could be more complex, of course, depending on what your domain is about. Now we also have a price class, and this class is a bit special. It's a so-called value object, which means that each object here is just identified by its value. So you can compare 2 price objects, and if they are of the same value, so if all of their properties are the same, both price objects represent the same value. This also means that a value object must be immutable. So every time the costs of a product changes, we have to create a new price object and pass this new price object into our product. We are doing basically the same as what we did in our product class. So we are validating the input. So maybe product shouldn't cost a negative amount because we don't want to pay the customer money if they buy our products. We are checking some other constraints too. And finally, we have our new category class, which also does some validation on the name. We don't have to validate the parent category because, of course, this one must be valid here. So when we are now using our new model with the forms that we have so far, we are running into problems. We won't go into detail what could be going wrong here, but basically if you just make the switch, your application will explode and your users will not be very happy because they will see internal server errors all the time, at least as long as they are not putting valid data into the form. And users tend to put invalid data into forms. That's why we validate them. So we need to find a solution which works around that and ensures that our model is always valid. And one option is so-called data transfer objects. And maybe you want to explain that?
Yes, it's my turn. So data transfer objects, so-called DTOs, are one way to solve this problem. So we can implement an additional class. In this case, it's a final class product with public properties. And on these properties, you will see their assertions once again. Okay? And we have one static method called fromEntity, where we have a single argument, which is a product entity, and we are creating a DTO object with a state by an entity. And we have a second method which is kind of a cast from a DTO to entity, where we create a product entity or manipulate an existing product entity. You see there's an argument, so if we have already, like if you edit a product in a form, you have already an existing entity, so we can now say, okay, the name of the entity is not the same name as the DTO value, so we can call the rename method. Same for the move to category or for the cost. So this DTO enables us to use the model with custom methods. Right? So the form type is quite the same, besides this little change that we bind the form to the DTO. Well, and in the controller, there are just a few changes. We have a product DTO from entity and a DTO to entity while persisting. So the controller takes care about the conversion between rich model and DTO.
Okay, so what does that mean for the data flow? Basically, not much is changing here. So the form looks still the same, the HTTP request looks the same, and also the request object here is the same as what we had before. What changes now is when we are looking at the controller. So first, we have to transform our entity into our data transfer object, because our form does no longer know how to map data to a product entity directly. So we are doing the transformation here. We are still handling the request, that didn't change here. And given this option here, our form type now knows that it has to deal with a product DTO. And this is the result after we have handled the request. And now this DTO can be valid or it can be invalid. It's just depending on the user input, and that's the reason why we put all the assertions that we had in the product model before into our DTO. And now, well, either the form is invalid, then this part is not true, and we will display the form type again, or the DTO is valid, and then we will have to fetch it here and transform it back into the entity that we had before, so that we can actually persist the data that we were dealing with.
So in code, we have the same setup like before, plus the DTO as a glue code. So we have to write additional glue code to make Symfony forms work with rich domain models. It looks like this. The controller has to take care about the model DTO thing, and once again here. So this is the additional part, and on top, the form component isn't aware of our rich domain model. So the DTO solution enables us to use rich domain models. It's quite easy to implement. You have seen the DTO class, which was quite simple. It is additional glue code though. And the validation rules are redundant. We have them in the rich domain model, and we have to implement them in the DTO as well. So that's an issue. And this impacts on the maintainability of this solution. So that's a con. Well,
that's one solution. The other solution is that we look into the form component in more detail. So let's see what extension points does this component offer to allow us to tweak or hook into the process and customize it to our needs. So the implementation looks like this. We still have the same controller that we had in our first example when we were using the Anemic domain model. So no product.
Short break. Who of you have worked with Datamappers before?
Oh, okay.
Okay, great. But if you haven't worked with Datamappers before and you don't totally get it, it's fine. totally fine. Because it's the hard solution, right?
You can read the demo application later on and learn at home if you want to. The controller looks the same as it was looking in our first example, because we don't want to deal with DTOs anymore, so we are passing product entities here. Yeah, it's the same. Our product type is a bit different now. So here it looks familiar. We introduced a new form type. It's called price type, and it's basically there to ease the handling of our price entity. And what's now different is this part. We are telling the form builder that we are replacing the built-in Datamapper. So the built-in Datamapper just deals with property paths, so it maps our name here to get name and set name method, and we have to replace that because our model doesn't fulfill this basic expectation that the form component has. And well, we can create a completely new object that is a Datamapper, or we just tell our product type to implement this Datamapper interface. This interface is provided by the form component and deals with mapping form data to the object and from the object to the form. How does it look? We have a map data to forms method, which does the part of populating the form with the data from our model. So yeah, we are catching all the subforms and passing the data that we can extract from our entity. More or less simple, and the same goes the other way around when we have to map our form data to our entity, and this time it's a bit more complex because we have to call different methods, and yeah, so it's a lot of code to write, but not that hard. And this part here is a bit funny, because when we are dealing with a form which is meant to create a new object, so for example a new product, we have to initialize this. And basically what the form component does when we are not doing anything special, it's just calling our constructor without any argument. And of course this will fail because we have mandatory arguments. So we are using the empty data option, and we can pass a closure here, which receives the form interface after submission, and then we can extract the data and pass it to our product constructor. And now we have to be a bit careful. We need to catch exceptions here, because our model is throwing exceptions when the input is invalid, and we catch them here, so they are not bubbling up until the exception handler.
This one? Yeah. Empty data. So, but no worries, slides and code is online afterwards, but it's empty underscore data.
And we are now attaching a form error object to our form, so that we can actually tell the user what's going wrong and what they have to change. And of course, then we don't have any product at all, and they need to re-enter data and reiterate here. So Dataflow looks like that. Should I do?
Do it.
Okay.
It's the same once again, right?
But basically the same. It changes a bit here because we now have nested forms, and this means that the resulting array here is also nested array, which isn't something we really need to be concerned about because that's handled internally by the form component. And here we are again dealing with a request, and instead of having the data class option here being important, we have our own Datamapper. So the map forms to data method is called here when we call handle request, and the request is mapped to the object, which then looks like this in case anything went well because the user submitted data that is valid. Otherwise, we would have caught the exception and we would have ended up here. Okay, quite simple, right? Not? Maybe?
Okay, on the code hand side, we have this before, and we switched out DTOs to Datamappers. So that was quite the same logic, just more moved to the form component. And we are not using the validator anymore, not directly. Right? It looks like it. So the controller doesn't have to care about the DTO anymore, but we have to extend the form type with an additional Datamapper. So the Datamapper solution enables us to use rich domain models as well. It requires a lot of knowledge about the form component and the extension points. And it's, once again, additional glue code. And it's quite hard to test. You always need to wire up a lot more stuff than when you're testing DTO to entity. All right, so we are still not satisfied. And you might be also not still. So we're introducing now the new rich model forms bundle, which is something we came up with in, I think, February, March, something like that.
Yeah, I think so.
And it took him a while to develop. Small disclaimer, this is still experimental, but it's out now. I think we released it about an hour ago, so you can already install it using Composer. But you have to go dev master, of course, because we came up with a simple use case like this, and we developed it using this use case and some additional ideas. But going DDD and rich domain means there are a lot of different use cases out there, and that's something you come in. And now we're talking about the features. So you saw that we had a get name and a rename method, so different read or write paths.
Okay, so yeah, before we either had to write a DTO or we had to implement a custom data map or whatever, and now we can make use of two new options. So maybe it's not really good readable, but if you cannot read it, I will explain it to you. So you have two new options. One is called read property path, which is just a property path pointing to a method or whatever that is able to read the data from the model. And the other option is write property path, which will then be called when you map the form to your data. So we are now able to say here, okay, when you need to populate the form, please make use of the getName method, and when you try to write the data back into our product, please use the rename method.
So two new additional form options to use. So next up, exception handling. Well, this is a constructor by the immutable value object price. So we need more than exception handling, but we're tackling exception handling first. So the problem is this or some setter or write path might raise exceptions, and we need to deal with it.
So if you think of the rename method that we used in the example before, there was a check if the name is at least 3 characters long, which would throw an exception as well, and we need to handle that if you don't want to present an exception to the user. So we can now make use of the expected exception option, which can receive one exception or a list of exceptions that might occur when you call the method that we specified using the write property path. So each of these exceptions here will be caught by the bundle and will be transformed into a nice error message. And additionally, every type error that may occur when you pass data to this method here will also be caught. So if you have, let's say, a method that expects an integer and you pass null, which happens quite often if you are dealing with classes that have type hints in PHP 7, so scalar type hints, then they will also be called here and will be transformed into a message telling the user that this is not data that was expected here.
By the way, the expected exception might sound familiar. You know it from PHP unit, I guess. And the read property path and write property path, now it's the name of the option in the implementation, but it's up for discussion. We wrote with Bernhard Schussig a while ago about this. Oh, sorry. Oh, God. This read and write property path, and you was not on the same page about that. But it's open source, right? And we have to agree on the sensible name for it. So maybe you have opinions about this as well. So come on, engage. And the next one is the mandatory constructor arguments as well, right? Before we used empty data to deal with that.
Yes, this was quite a complex anonymous function, if you remember. So that's not really something we want to write on our own because it makes form handling very complex. And now you can make use of the factory option. And for example, you can pass a class name there. And this class name must have a public constructor, which will then be used. You could also pass an array if you have, this array must be a valid callable. So you may have a static method that you want to have called, and then you can just pass an array containing the class name and the method name. I think you can also pass an anonymous function if you have to do some logic depending on the submitted data.
So the next one is that the price object is an immutable value object. So we cannot transform it, but we have to recreate it on change.
So yes, the factory option itself would only be applied in case there was no data object that we could map to. But in case of the price, we need to create a new object every time the form is submitted, because we cannot change existing instances. So we thought about a new option which we call immutable, which just indicates that the underlying data cannot be changed. And every time data is submitted here, a new instance of the underlying class must be created just using the factory that we specified here. So the combination of these two options makes it possible to use value objects at this stage.
Okay, I guess we're running out of time, so we have to rush a bit about the implementation. The implementation it's still the same like in the first place. So the controller isn't aware of that. And we have to extend the product type, so the form type. And we're adding the read and the write property path and the expected exception as well. So, and down here, we even have an expected exception on the a complete form with an array of expected exceptions. And this turns out to ease the part of the code we have to write, because the rich model form will take care about the transition between the request and the rich domain model. And that means that we don't have to write a Datamapper anymore, but there is no glue code additional. So this looks exactly the same like the first code slide where we used the standard way, right? So our form type, our form component is now able to use a rich domain with those additional options.
Okay, so if we just summarize what we have seen so far, is the rich model forms bundle generalizes all the ideas that we presented before. So we thought about use cases that we would have when dealing with rich domain models and what problems would we have to solve. And we try to find more generic solutions for that, which are just configurable on the level of our form types. So you don't have to think about forms when writing or when designing your domain model, you just think about your domain, design your model, and then you make use of these additional options to configure your forms to just deal with what you really need here. And this aims to ease the handling of rich models inside your forms. As Chris said, we released the bundle today, so released in terms of the code is public now. You can take a look at the code, you can try it out in your own projects, and I'm pretty sure that there are many features missing at the moment, so we would need your input in what use cases you have, what problems you would like to solve with this bundle or similar approaches, and what is currently not possible. We are aware of the fact that there are things that are missing right now, so we will need your input to discuss what would be fitting in this bundle. And yeah, we don't use it in production right now. Some of the approaches there are really taken from projects, but this general approach is not used in production right now.
So,
oh, sorry.
No worries. Now it's your turn to help us to get it there, that it's stable and we can use it in production, and maybe move some of those ideas to the core. And yeah, that's it. Thanks.
I think we have some time for questions, right?
I don't think so, but we are here the whole day, and we're here right after the talk. But very important, give us feedback on Joint, and we're going to give this talk a few times, so it would be great to improve it. This was the first time on a big stage, so feedback would be great. Thanks.
Thank you.